Okay, so we'll get started again. So I'm going to hand straight over to Justin Curtis from Sikorsky.
Thank you.
We'll cover that side, of course.
Hello, everybody. My name is Justin Ferris. I'm the field service rep with Sikorsky. I support the Gulf of Mexico region, S-92s and S-76s. Also have some aircraft over in Florida, up here in Dallas. I've been with Sikorsky for almost 14 years now, field service rep for Dix. Prior to my time coming to Houston, I was over in the UK, in Aberdeen, Scotland, supporting offshore oil and gas in the North Sea, HM Coast Guard, which is, I guess, His Majesty's Coast Guard now.
Yeah, it's a little bit, yeah.
And Irish Coast Guard.
I imagine all the costs are changing all that station.
Yeah, well, I mean, it's just HM,
Yeah,
right?
but I guess they spell it out somewhere.
Yeah. Yeah, today I'm here to go over a technical brief about the S-92, some projects, some project improvements, some maintenance improvements, some safety projects we got going on.
Oh, click up. Oh,
Oh, sorry, you know what, I turned it off.
oh, no.
It's
Oh,
yeah. It was just working.
So do you need somebody to? I can do,
Change your
yeah,
slide?
I'll just sit here and do
Okay.
the next slide.
Yeah, I was really hoping to-
Okay.
Well, the pointer still works.
I can do it. Next slide.
You did pull the battery back out?
Oh, do you know what? I don't know if she's not just put. That's weird. There's a whole presentation was frozen, I think. Try it now?
There we go.
Yeah,
Good.
the presentation had just frozen. No.
So quick overview of the S-92. Right now we have 263 operational aircraft. We've delivered well over 300. We just have the downturn in oil and gas and stuff. A lot of them were in storage. There's been a few airframes that were parted out. And then the airframes actually scrapped. But we're slowly starting to see a lot of them come out of storage. We just recently hit over the 2 million hour flight hours. This is just worldwide, where the S-92s are kind of there all over the world. A lot of them up in the North Sea. That's where a lot of the offshore oil and gas are. They keep them busy up there. And like I said, predominantly the S-92 is offshore oil and gas transport. It sits 19 passengers. You know, it can fly. It's got a great range, great safety record, and it's they're good. Also used as for search and rescue. His Majesty's Coast Guard now, this depicted here. The Irish Coast Guard uses them. We have one in the Gulf of Mexico, one up in Alaska. We got search and rescue in Asia, so they're real popular with the search and rescue, just the low capacity. You know, the SAR FCS that they have fitted with it, it's solid for search and rescue. And VIP. We have quite a few aircraft now that are VIP. A lot of countries are starting to pick the S-92 for the head of state operations.
Do you have any that are commuter? Charles? Any commuters or they're all privately owned? The VIP 92s.
Yes, well, they're, I believe,
Like anybody doing helicopter shuttles, airports and stuff like that, or?
No.
Privately owned.
not that, I'm almost positive they're all private. There's only in the United States, I believe there's just the one, the Renko one up north. There's been talks about getting some more down in the south, but it's a big cost. And then, you know, we have several throughout Asia and Europe, and they're all privately owned. So some safety projects we got going on. So a few years back, main rotor, stationary swash plate. This was actually found cracked. You can see here, this is the stationary swash plate. So in the 2 million flight hours, one, it's the only ones that were found. And it was found in the visual inspection. We have a home system, health and usage monitoring system of the aircraft. Accelerometers all over the drivetrain, the airframe, nothing was picked up. So this was taken back with disassembled. This actually happened while I was over in Aberdeen. So I was able to go there. We removed it, pulled into a back shop, pulled the uniball out, done all on video, you know, all the Sikorsky programs and quality, safety, everybody wanted to see what was going on with it. It was very high visibility. Sent back, they did their analysis. So what ended up happening is we released a service, the service bulletin is ASB 9262010. So this is to implement a 50-hour recurring inspection for swash plates over 8,600 hours. Now the 26.5 is for max takeoff weight aircraft, 26,500 pounds. A majority of the fleet operates at that. Now there is a handful of aircraft that have the gross weight expansion. They can have their max takeoff weight up to 27.7. And that is a recurring 50-hour inspection at 3,300 hours. Now the recurring inspection is an NDT. You can do a die pen or eddy current. And it's in, you know, these are the red areas here. This is the center of the U-balls here, main rotor shaft. And it's, you know, it's a time-consuming inspection, especially if you don't have somebody that can do eddy current. You got to have somebody come out and do a die pen. You got to strip all the areas. So there is a new swash plate in design, and I don't have a timeline on it, but it's definitely in works. It's, you know, it's a big inconvenience for offshore oil and gas operators that are flying these things, you know, 50 hours every 10 days. Tailor pitch change shaft improvements. So we've had a few cases where there was some reports of restricted pedals. We did have one case where the actual tail rotor pitch change shaft bearing seized. So what we did was we implemented in the tail rotor pitch change shaft, we actually put temperature dots so we can monitor the temperature of the bearing. But that was something it was a visual inspection. Every 10 hours, you have to pop this cover off and check temp dots to make sure nothing's tripped. So what we're doing now is this is an accelerometer that's going onto the tail rotor servo that will be able to monitor the pitching shaft vibrations and everything more closely. And the main goal here is to, one, I mean, you know, monitor the pitching shaft better, but also to get rid of that 10-hour recurring inspection of the temperature dots. And this right now is, we have many operators that are installing this. This is the accelerometer on the end of the on the servo. Still in data collection phase, but it's it will be released in the future at the ASB. If anyone has any questions about any of these, like, please stop me. We don't have to wait till the end. The number 2 tail rotor drive shaft coating. So the number 2 tail rotor drive shaft is located inside this duct. This duct is after the transmission. What mounts on top of here is actually a heat exchanger for the transmission oil. And what it does is it pulls, well, this is all spinning, it pulls air in here, forces it through the duct and up through the heat exchanger to cool the transmission oil. Now, a lot of the, we haven't had any failures or any accidents or anything, but there's been a lot of on inspections. They will find, as you can see here, something gets stuck in through that blower, gets stuck in that duct. They were always finding some sort of damage on that aft end of the drive shaft. So we implemented is a tungsten carbon coating that's going to be applied. It's not released yet. Hoping to have certification soon. Q3 2022 was the target, so it's coming. And then we'll issue TRED in the maintenance manual. This will be a whole new part number. This is not going to be something that can be added in the field. It will be done by attrition. So it's, you know, order a whole new drive shaft. Station 305 side frame cracks. As you can see here, these are pretty significant cracks that have been found on a couple aircraft. You know, that's a big job. It's a frame change. So these are, I mean, as the S92 is aging, you know, we're starting to find more and more, you know, things that are affecting these older airframes. This particular issue, we'll implement an ASB to put this strap here to beef up the area. And yeah, I mean, it's just kind of going back to the importance of, you know, this is obviously covered by all interior. So the way to see if you have all the interior out. So it's making sure you're doing those good GBIs when this stuff is all opened up. Fire bottle auto discharge. So we had inertia switches located up in the top, up in the upper cabin, and they were for a period of time there. We also have ABC. It's a vibration control. So that we were getting accidental discharge reported because of these, you know, they're big force generators. They got weights that spin around to counteract airframe vibrations, and they were actually discharging the fire bombs. So we got rid of those, and now we're relocating those inertia switches to the right underneath the pilot and co-pilot seat. And this was, we released it on our service bulletin, 92-26-008, and compliance is due June of next year. Side-facing utility seats. So during review of these seat fittings, that they determined that the load data that they used was incorrect. So this is only going to be applicable to aircraft that are configured for search and rescue that have the capability of putting the side-facing utility seats in. It's not applicable to aircraft that are, you know, oil and gas transport that have the forward-facing airliner seats. So the load analysis was done incorrectly. It was done for that the load was on the floor when it actually, like, these seats actually hang off the sidewalls. I don't know if anybody's familiar with troop seats, but you can see, yeah, they clip in. Yeah, so this was done, like I said, it's only applicable to search and rescue aircraft, and it's got compliance dates today. So all the search and rescue aircraft that have this should be done today. Some ongoing maintenance projects, maintenance improvements. So the next couple slides I have are related to main rotor track balance issues. One of the big issues that we've had is some bad main rotor dampers. So the main rotor dampers They have, DC 510 fluid. Whoops. In them, so I mean, you got your piston here, in and out, dampens the lead and lag blade. Arkman is the manufacturer, so we kind of went back and forth with them. They ended up, doing some improvements, on it. They did the shell valve improvement, or leaf valve. Now we can do this orifice valve adjustment, because now when they come out of, we're getting them from the vendor, they mount them on and technicians get on there and they can't move blade, they can't lead or lag. So it leads to all sorts of track and balance, issues, can't get main orders tuned properly. So like I said, we have the orifice valve adjustment that it gives some relief. You can at least get them leading and lagging. And Arkman and Sikorsky now, we're still working with them to get their acceptance procedure. You know, before it leaves Arkman, to make sure it's, you know, the pistons move back and forth like it should, before it gets to the operators. This causes a lot of, a lot of unneeded maintenance, a lot of on and off with the stamper, and just a lot of time doing track and balance. I'm sure everybody's familiar with track and balance, but you burn some fuel, it can be expensive. Next one here is this is another issue we've been having. We've had several blades, and actually we've turned them road blades. So as these blades are older and older, I mean, it's a lot of them have repairs that have been incorporated. It kind of changes their balance, and a lot of them you can't stick them on aircraft, and it's just can't get them tuned in order to track and balance problems. Do your weight adjustments, your trim tab adjustments, and just struggle with them. So we have a list of blades that, you know, have been put on several different aircraft. Can't get the track and balance incorrectly. So what our NVH team, which is noise, vibration, and harshness team, they came up with to do the chord-wise, the span chord-wise blade weight adjustment. Now, this isn't anything that the operators can do on their own. It has to get done through Sikorsky. So with our HUMs, they're able to download all their data. They log on, they put it into their ground station. And it all gets uploaded to Sikorsky, and we can review all of their vibration data, track and balance data. And if we see that, yes, it's got a blade on there that's has been identified as a rogue blade, but they're confident they can get it in, we will issue engineering instructions to go ahead and do these adjustments. So it's kind of it's on a case by case. Make gearbox chip criteria. So we've had several incidences with on the main gearbox where they might get fuzz burning indication, which is on the ground station. They could get maybe a chip indication, maybe something, I mean, very small, something bridges the gap here, and they get the gearbox chip, or input module, accessory gearbox chip indication. The big one was at 375 hours, we tell you to pull all the chip detectors and inspect everything. Now, serviceability checks on the S92 is pretty in depth. It requires draining all the oil, doing a 30-minute or resurfacing everything, doing a 30-minute ground run, a 30-minute hover or flight, come back, re-inspect everything, and it can be quite time consuming and quite expensive for the operators because this thing holds 10 gallons of oil. So I mean, you're draining and discarding it, it can add up. So in the maintenance manual, in our criteria, it would tell you if you had a certain number of debris that you gotta remove the gearbox. So with working with, the customers and our transmission team, you know, it would say, all right, the FSRs would look at it and like, well, let's have transmissions, you know, look at whatever debris that you're showing. Engineers would come back and say, no, just do the serviceability check and then re-inspect 10 to 20 hours. 9 times out of 10, they do serviceability check, they re-inspect everything 10 to 20 hours and everything is going. So yeah, so now what we're doing, depending on this, so there's criteria here, but if you find debris in 375 hours and it's under a certain amount, you do not have to do a serviceability check, you just re-inspect in 10 to 24 hours. Which is the last thing an operator wants. You know, is to be wasting all that oil and then to get stuck offshore. They get stuck offshore on a platform someplace because they got a chip detector. It's you know, it's tough, especially some of these rigs just have one spot for one aircraft. So a lot of times we got to kind of push the aircraft off to the side and they'll bring another aircraft out with a hoist the technician down to be able to do all this work. So it's it can be very expensive. Main order blade, the nickel strip, the abrasion strip. So we've been working for a long time to get this criteria expanded out. It's caused, I mean, we but sent back so many blades, due to this being out of tolerance. Now, I mean, when you're changing a main rotor blade, then you run back into the, now you gotta balance everything again. Now you run into the issues with the damper and the rogue blade, and this is, so it's trying to avoid taking off the blades if you can. So all the operators, a lot of the FSRs work together, propose some limits. And it got approved. It's actually doubling right now current allowable limits for discount on the abrasion strip. And it's didn't work to get incorporated into the manual. And right now it's only for non-RIPS aircraft. I don't know if anyone's familiar with RIPS. RIPS is rotorized protection system. Each main rotor blade, tail rotor blade, they have sections that will heat up to shed ice, allow them to fly into icy conditions. And it's in works for the RIPS aircraft. I don't know if I'm going too fast here. Main rotor yoke. So main rotor yoke is it's where the main rotor blade and the damper actually attached to. So this here, this bolt that's shown here is where that damper that was back in fuselage actually attached to. On inspection, they would find that this force main bushing was worn out of limits. Now we could give a concession, you know, if it's worn just a little bit out of limits, we could give a concession to you know, to keep an operation for another 100 or 200 flight hours, depending on what the limits were. But the big problem is that now you have to disassemble this all, you pull the yoke off, you got to pull the blade off, you got to disconnect the damper, you got to pull the yoke off the head to install a new yoke. So what we came up with was a fix that you would be able to do on wing. There's a sacrificial this slip fit bushing here that will go on instead, and instead of changing out the whole yoke, now you can just this slip fit bushing comes out and put a new one in. This is going to get done Yeah, by attrition and by the 750-hour inspections, we're doing all this work up there. So yeah, the projection is to have it in the field hopefully by this time next year. Intermediate gearbox, tail gearbox, input the seals. Been working for a while on this, getting some improved seals on IGB, TGB, and the tail takeoff on the main gearbox. Just to try to make them better. We have a new seal design now. It's this bi-directional Teflon seal. We went and tried to install it, and it came up that you actually are going to need a special tool to install it into these components. The goal would be that it's a kind of a sacrificial tool that comes with the seal, so you use it, the fitting that would go around it would fit on your seal installer. It would push it in so it doesn't roll or lip over, and then it's kind of a one-time use thing. That's the proposed right now. As soon as that's validated with Sikorsky, we'll go ahead and push it out to the this is the LTF is called, it's lead to fleet. Find a select few operators. Usually it's the bigger operators, the guys that are flying, 5-6 hours a day, offshore oil and gas aircraft, and they'll agree to do the lead to fleet. They'll put the aircraft on, they'll monitor, or they'll put the seal in, they'll monitor it, and report back kind of how it's doing. This is very common to do stuff like this. I don't know if it's with other manufacturers or not, but. The afloat cover repairs. So this afloat cover that goes on the underside of the tail boom is made by GKN. It's not repairable. So every time this thing goes off and on, there's these little holes here that bolts to the airframe. The float sits inside here. Every time these things go off, they weaken, they get cracked, somebody's too hard on it, but they're not repairable. So we went back and forth with GKN, and GKN's big concern was, well, they need to come back to us because there's a break lever. Can't have it too strong, because then maybe the float won't, can't have it too weak, because then maybe it'll just pop off on its own. So we worked for a while. This has been going on for some time now, but we finally got the approval. They ordered a new float cover, and GKN is actually going to review our proposed repair. They're going to, I'm assuming they're going to break all of these, and they will, they'll do our repair. They'll do the breakaway test, and if everything holds up, we're hoping to add this into our SRM soon, just because this is a big cost for our operators. Keeping these on shelves, sometimes even getting them is tough. But yeah, every time you find one of these cracks, you're pulling this panel off minimal once a year. The floats have a 12-month inspection, so it's really common to see these all busted up, like you see here. So yeah, that's a little product improvement thing that hopefully we'll complete it here soon. Pneumatic engine starters. So I don't know how many, is anybody familiar with pneumatic engine starters, or are these all, is there DC starters? Yeah. Mm-hmm. So we had an issue with failures. So this here's the shaft. This is the bleeder that comes in. right here, rotating a starter, turning the shaft rotates, your accessory module, and your aircraft starts getting ready to move it, and then it lights off that way. Now, as you can see here, the casing on this one actually failed. There was a big investigation because we did have several of these. But the root cause was the fit between the jack shaft and the housing, allowing relative motion at operating temperatures. The shaft would wear into the aluminum housing and lose its center, and then it would just lead to failure of the gear. There is some corrective actions, Honeywell and Sikorsky. They're going to tighten the jack shaft house fitting, change to a harder type 2 anodized, upgrade the jack shaft material, increase the oil capacity that's in these starters. These are filled with engine oil, and they're going to add another chip detector. So you will set up a frequency to be able to check, pull the plug, and look for any debris. And there is another design coming out as well, but it's I mean, the completion date, they say by the end of this year. I'm not sure if that's gonna hold or not. Yeah, this would be a good one. I know this can be very time consuming and expensive as well. These things shear, especially if you shut down offshore and then shear your shaft, and I guess some technicians out. Case cut, it doesn't look good, especially if somebody open up the engine count, you can see metal and gear pieces and oil all over the place.
Would you be able to cross blade if you needed to, or no chance to cross blade?
No, you can't, 'cause you can't.
And it's hard.
Yeah, there's been, even with the current one that's out now, like here, I mean, it's mean time before and schedule removal has improved drastically with the 102, and we're hoping it'll be even better with the 103. Fuel probe collar. So in our fuel cells, you have 2 fuel probes on each side. Anytime they would, technicians would go in and do any type of inspection, everything would be operational, the fuel probe would be working fine, but where it mounts inside here, you can see this crack. So it was determined that, it was due to this rivet here, it was too small, and it was just, people jamming it in there, stressing it while attaching it with these quarter turn fasteners. And yet this is not field repairable. This calls for deemed the Pro 1 serviceable. The economic frame would not give us a repair for it. They were too worried about FOD. FOD and fuel cells is not ideal. So what they're doing now is, so the lab analysis shows collar crack issue to crush plastic from the rivet install. So they're going to do a larger bore for the rivet. It'll be less preload here, and then a more pliant collar material, so it can take somebody like tech in there kind of moving things around and forcing around. We have implementation of this design is underway. Estimated completion date is Q4 of this year. This has been a long one too. This has been a long battle with the vendor. The RIPS measuring head. So like I said, RIPS is rotorized protection system. On the engine inlets, you have this component here, is the ice rate detector. Now, we were having some problems, a lot of reports of these ice rate detector failures. And it was, once you take it apart, we'd send it back, they'd take it apart, they'd say there's corrosion found on the inside. You know, because it's obviously we can't pull this stuff apart. This is all Curtis Wright, does all this stuff. That there was evidence of moisture getting into the inside. Well, a lot of these aircraft fly, the majority of our S-92s that fly offshore oil and gas that are fit with grips are in the North Sea. So it's very common to be flying through significant amount of rain. They sit outside on the ramp, they get wet, snow, cold. So what we did is we reviewed the sealing process of actually how this is installed onto the inlet. Seal it up better in hopes to limit some of that water. And then also the seal here is basically covered. You can see how there's water and stuff in there. So we're going to incorporate some better procedures in the AMM. Hopefully start to reduce these failure rates. As you can see here, there's, you know, on this board here where the water starts coming in, there's a rubber gasket that sits below this cover, corroding these circuit boards, and that causes them to fail. And this is another time-consuming, you know, for the operators. And then you gotta be down the aircraft, you gotta take the inlet off, you gotta disassemble the inlet, put everything back together, off check everything, so it could be, you know, for this failure, if you're flying in the winter time, you do need grips. You can't MEL this. I mean, you can pull this aircraft down for a day. And that's it. That's all I got. Do we have any questions?
How many S-92s are out there with reps, do you know?
I don't have an exact number.
Percentage, but
So, I mean, I don't have an exact number, but I can tell you. All the ones you see here up in Europe, they all have rips. Asia all has rips. Canada will all have rips. Gulf of Mexico, they typically will remove it, save it in weight. South America, the same thing, they remove it. We had, I would say, I bet you half the fleet.
yeah, that's sometimes a tricky system to work with. Small helicopters.
Yeah.
You know, on the 39 side. What was it on? Hit or miss, kind of.
Yeah.
As you reach your next program,
Good. I think it's, I mean, it's, as far as I know, it's come along well. It's,
you say when they're gonna be online?
I don't know, I don't have an answer for sure. You know, we hear different things, but I don't know. So I don't have an answer. But it, I mean, soon. I'm sure it's gonna be pretty soon. It's, yeah, we get pictures every once in a while of the S-92 all painted up with the white top. And yeah, it'll be, I hope that program goes well. I think that's why a lot of these other countries too are. A lot of these countries start thinking S-92 or choosing S-92 for their head state programs. We recently just delivered to Morocco, Uzbekistan, Korea. They've been flying their white tops for quite a few years now. But yeah, I mean, it's a cool machine when you're in there. There's a bathroom and with showers in there. And I mean, it's like flash for 4 hours. Okay. I don't think it's 50 minutes.
That's fine.
Good.
And if there's, so one of the things we had in theory in the program, a 30-minute kind of further Q&A, but I think we perhaps exhausted everything that we've got here for this one. I was going to make a proposal. We've got, So I don't know, is James Danger still here?
I'm right here.
Oh, you're there. I was going to suggest, I'm going to contact, because Kylie Kay is also then doing the session later. I'm going to drop him an email and see maybe, and if you're happy, we carry on, and if Kylie can do it early, then we maybe finish it slightly earlier today and do it that way.
Oh, that'd be great.
Yeah. Do you think that's a good idea? Rather than, we can take a break now and come back in 45 minutes but I don't know if there's any value in that. Maybe if you're ready to go, we can set your presentation up and do yours. In the meantime, I'll email Kylie and see if he's ready in like an hour or so, and then we can kind of run from one into the other. That should work. I'll hand straight over to you, James, and let you start whenever you're ready.
Yeah, no problem.
No rush at all. I'd say I'm really excited about this one because when I was in the Air Force teaching human factors for maintainers, we used all of this stuff that you created, that the FAA created, that underpinned the whole UK Defence Maintenance Human Factors Program. So to actually see it delivered from the people who created it, I'm really excited to see it in person.
I'm gonna text two people real quick who said they wanted to attend, so I'm just real quick so they're aware.
Talk amongst yourselves for 2 minutes while we just sort of logistically just email Kylie.
Grab the clicker. Is the presentation already up and ready? Oh, there it is, yeah.
Yeah.
Okay, awesome.
Just check it moves forward.
I'm gonna practice and make sure it works. Yep, that's good. And then the video, there's a video she's gonna play for me.
Oh, okay. Yeah, I can.
Sonia.
Yeah.
She should already have it up and ready. It should be halfway through, but we're gonna do it after like the third or fourth slide.
Okay, just shout me and I'll jump up.
Okay, so welcome everybody. I'm James Dangerfield. I work for the FAA. I'm out of West Columbia, South Carolina. I'm not from Washington, like this says. I'm a helicopter guy. I've been a helicopter guy most of my life. I went into the Army at age 17. I was a Cobra helicopter mechanic for the Army for 3 years, and then went straight from the Army into the National Guard. And in the National Guard, I became a quality control inspector. I worked on Apaches, OH-58s, and a little bit of Blackhawks, not very much. And then while I was in the Guard full time, I started working for Rocky Mountain Helicopters, and then Air Methods when the contract changed at one of our major hospitals in Columbia, South Carolina. And then I worked for Air Methods and Rocky combined for about 14 years as a relief mechanic, which meant I got to tear down AS-350 B2. You know, we do those overnighters where you just worked on the aircraft all night long to get it back up. So I got a little bit of experience with that. I also have my fixed wing pilot's license, and I owned my own airplane for about 8 years. Fixed it up from an old junker into a nice aircraft. I'm trying to remember if I got that in the slides. Let's look and see. So I took the fixed wing Dirty Dozen that you were talking about earlier, which Transport Canada wrote. It was written by Gordon DuPont. He's the one who came up with the program. And then I took the FAA version that we've written. I think the original author's name escapes me right now, but I'll let you know. He wrote the fixed wing Dirty Dozen for the FAA, and then I converted it to the helicopter Dirty Dozen. And so this presentation took me about 3 years to write. And what I would do is each time I brief it, I'd learn something new from an audience member about an accident, and I would try to tweak the presentation, make it a little bit better. All the FAST team does is promote safety. We don't violate people. We just go out and help you with safety. And we teach your people for free. You just ask us to come. And there should be a FAST team member in every single state. Thank you for coming, number one. I appreciate it. I'm going to make this an interesting briefing. I don't want it to bore you. I don't want you to fall asleep. So I'm going to do my best to keep it interesting. And we're going to do some accident deep dives where we're actually going to go in and look at all the human factors that I can determine caused the accident. But thank you to all those people up on the list. You could make sure your phone is silent if you don't mind. And And of course, this is the overview of the Dirty Dozen. This is what the FAA and of course, Transport Canada said. These are the human factors that cause accidents that we were able to identify. And so every time you have an accident, you actually determine which human factors were involved in that accident. So, Tanya, they said, go ahead and start if that's okay. Is that good?
I think the virtual people though.
Yeah, I don't know about the schedule. Oh, yeah. Do we need to hold tight or you can let me know?
Go ahead. Go ahead.
I made an executive decision.
Okay, that's fine. Well,
I'll take the blame.
okay.
Are you ready for that video, Tanya? I know I'm
Yes.
keeping you at the last second. So I want you to watch this video. She's going to show you, and I want you to look at this, put your safety hat on and go, what would I do different in this event? What safety gear would I carry? Think about what you see and say, how would I have handled this differently if I was prepared for any kind of accident that could happen? Sounds not important, but the video is the most important part.
C'est bon, c'est l'encre.
Remember the half, Tanya? You don't need to see. Get to the mid-market good. There you go. Thank you. So think about the safety gear as you were doing this. And that is the ocean in the background.
C'est ok? Marche arrière.
That's a sailboat pulling away from them.
Ah bah non, ils s'en foutent du fond. Bon bah à l'année prochaine.
Ciao.
Oh, yeah, they did.
Oh putain! Oh putain! Merde, vite! Retourne dedans! Retourne dedans! C'est bon. Un bout! Un bout! Vite, vite! Allez, les enfants!
So, give me some idea, what would y'all have done differently? What would you have worn? Or what kind of safety gear would you have had?
Would have stayed on the boat.
Hey, this is like aviation. There's risk in everything you do. You have to prepare for that risk just in case, so.
They weren't dressed for swimming, that's for sure.
You're exactly right. What do you recommend that they wear?
Immersion
Proper immersion.
have a tether.
That's good. What else? Anybody else got a simple solution that's cheap and available? That almost every boat has?
A life vest.
Life vest or life preserver. My gosh, a life preserver would have been wonderful. Even the kayak life preservers where they have the big openings in the arms so you can move around. I mean, that would have been the ideal thing to have in my opinion. So that is a great video because it makes you think about how would we do that differently? Let's see what happens. And these people were not ready for it. So, and they had spiked shoes, which weigh a lot. They had their little pickaxe, which is very expensive, which is probably near the bottom of the ocean. Just think about all that gear that they had on, and with a life preserver, it could have at least kept them buoyant for a little while while they were taking all that stuff off.
Sorry, I messed with your presentation.
No, you're good. You're good, Simon.
Do we know if they survived? Were they?
I think they did survive. Yeah. I don't know if they dumped all their gear or what. Somebody was saying here earlier, I think that might have been you, Justin, that said that those jackets might have given them a little bit of buoyancy.
For a little bit.
Yeah,
but
yeah.
not saturated.
Yeah.
It looked like they were those pump jackets.
Oh, yeah, yeah.
I would assume hold some air, they probably would have. You saw them kind of float up a little bit.
Yeah, yeah.
But I mean,
Yeah.
they would be able to stay up for sure.
So this is the actual slide out of the original FAA Dirty Dozen because it's hard to find somebody ejecting out of a helicopter. Okay. Yeah. Does anybody recognize this airplane and who flies it? Yep, the Thunderbirds. Do you think those are mediocre pilots? So this gentleman here was flying his F-16, preparing for an air show. He set his altimeter for his home base and not this location. So he misjudged the ground by 100 feet, knew he was going to collide with the ground, so he ejected. So the question is does the Air Force choose mediocre pilots? No, they choose the best of the best of the best. And the people that are the best at what they do usually get the most high risk things to do. You know what I'm saying? So Nobody's perfect. Mechanics make mistakes, pilots make mistakes. Thank God, we've never made mistakes that have ever killed anybody, but there are possibilities. So, and it can happen, even to the best people. Now, I did find a helicopter somebody ejected out of. Have you ever heard of this one? No. Does anybody see anything weird about this picture?
Yeah, it's Photoshop.
Yeah, it is. Exactly. It's a joke and not real. I had to put that on there because we did an international virtual seminar and they said that some people might need that to understand it. But yeah, the door's still on the aircraft. This is the Bell 206. The doors on the aircraft can be pretty hard to eject out. I mean, if you want to make it believable, at least take the door off. But it is fake. Yeah, it is fake. We're not going to watch this, but if you want to take a picture of it, you can. We have, within the FAA, we promote safety. And you'll see Randy Rolls in most of these videos. We have a system called the Rotorcraft Collective or presentations that we do online. You can go search them on YouTube. Randy Rolls is the main presenter on 90% of the briefings that we do. And then Bruce Webb also helps out with them. And then I got lucky enough to be in one myself, which is called pre-flight inspection after maintenance, which is I enjoyed doing. I really did. It's got a lot of views compared to the pilot videos because there's very few maintenance videos out there. But yeah, you're welcome to check that out when you get some time. Here are the Dirty Dozen. These are the original Dirty Dozen that I know of. I have seen some new versions come out with some different. One of them is Bad Habits. I'm not sure where that one fits in, but they replaced a couple of these and some other corporations who kind of borrowed these. So, but these are the original. We're going to cover each one of them. Most of them are going to be covered in this one accident right here. I'm going to try not to read many slides here, but I'm actually going to read this one because this is the most important accident investigation for most of the Dirty Dozen. So on July 2010 at about 1:42, an Air Methods Corporation American Eurocopter AX350B3 medical helicopter, November 509 Alpha Mike, during a VFR flight on the Part 91, descended rapidly and collided with terrain in Tucson, Arizona. Aircraft was substantially damaged and consumed by post-impact fire. The pilot and two medical flight crew members were fatally injured. The repositioning flight was for engine coking maintenance, originated at the Marana Regional Airport in Tucson at about 1:32 p.m. You notice it's only 10 minutes to start. God bless you. From the beginning of the flight to the end of the flight, and the intended destination was the Air Methods base in Douglas, Arizona. Just to let you know, we're going to have two corporations involved with this. We're going to have Air Methods and we're going to have Helicopter Services of Nevada. They were the two organizations working on this aircraft. I want to mention one thing right in the beginning. They're professional organizations trying to do the right thing. But what happened was the Swiss cheese, have you ever heard of the Swiss cheese model? Too many of those holes lined up on that one day when they flew this aircraft. And it all just, you'll see those holes as we go through and talk about each one of the Dirty Dozen. So these are very, very professional organizations, trust me. This is the actual accident aircraft, which is an AS350B3 model. Has a turbomeca engine in it. This is the aftermath of the crash. I'm going to cheat and look at my notes because there's some little more detail in this, in the notes on this. I'm going to mention some things here, and we're going to talk about a little bit of it. So the witnesses reported observing the helicopter flying steadily in a southeast direction when it started to descend rapidly. Witnesses stated the helicopter made some unusual whoop whoop noises, rapid intermittent popping sounds, followed by unusual quietness as the helicopter descended. As the helicopter turned, got closer to the ground, its flight trajectory became increasingly vertical, and it hit a 5-foot-high concrete wall that you can see in the picture. It looks like the outline of a house without the top of the house, and you can see there's a concrete wall right there. Now I'm just going to guess this. I've got some of the stuff in the notes, but he did auto rotation because he lost engine power, and he misjudged this distance because of the full fuel load and the fuel crew, or full crew, and ended up landing inside of that home and tore off the tail when he crashed. Back then, the A-Stars had the plastic fuel tank. I think most of them still do. They did brief about the new crash resistant fuel tanks. Let's see. And we'll go over the details of the accident in a minute. So here are the Dirty Dozen posters. And if you understand the posters, oh, by the way, I forgot to mention this. Make sure you scan the QR codes in the back of the room when you're either during the presentation or at the end, so you can get the AMT credit for this presentation. These are the posters, and if you look at it, they're laid out a certain way. The Dirty Dozen are at the top. The one that's highlighted in white is the one we're going to cover. And then there's actually mitigation things that you can do to prevent those Dirty Dozen from happening. The highlighted and lack of communication, you can use these items to help prevent it. Never assume anything, discuss work to be done, and use log sheets or log books and worksheets to communicate and move out. So I like that layout. Okay, so here's what we're going to do. First thing I'm going to do is throw the FAA under the bus. I figure I work for the FAA, I might as well. Humility goes a long way in briefing a crowd, in my opinion. So lack of communication, the first thing that happened was after the accident, the NTSB takes over when there's usually a death involved, because there's so many more FAA inspectors than there are NTSB inspectors. We've got about 5,000 in the FAA that go out and inspect aircraft accidents. NTSB probably has about 150 aviation inspectors or less. So they mainly go to high profile accidents, and then we cover the small accidents where there's no deaths. And we also cover the accidents where there are deaths when they can't make it to it. But the NTSB, of course, is always in charge of the investigation. But this particular accident, so remember I mentioned there's Air Methods who actually own this aircraft, and then they've got helicopter services in Nevada. This aircraft went in for engine coking maintenance at a remote station, not at Helicopter Services in Nevada's main repair station. Okay. Normally, if you're able to work away from your home station, you get a special OPSPEC. And I don't know if you know what OPSPECs are or not, but I like to cover that for you. They did this heavy maintenance where they took the engine out and did all this work and disassembled it, put it back together with one Helicopter Services in Nevada mechanic, and then the 2 Air Methods mechanics. And I'll go into more details in a few minutes. So the FAA inspector said that Helicopter Services in Nevada did not have a work away from station OPSPECs, and I'll show you what they look like here in a minute. But the owner of the repair station said that he doesn't remember ever signing this A004, or I'm sorry, you need to sign A004. He actually signed Delta 100. I got to fix that. Here's the example. A004 is actually a table of contents. Or am I mixed up here? Yeah, here it is. This is the table of contents, the A004, and it takes you to D100. D100 is over there. And it states down here where you see all the red arrows, the certificate holder may not perform continuous operations at a facility other than the station's fixed location listed in paragraph A001 and paragraph A101 if issued. And they mention in here that there are certain things that they can do remotely. So they had actually taken away this authorization for Helicopter Services in Nevada to do this heavy maintenance, and just gave them the ability to do temporary maintenance, like small stuff like light bulbs. They mentioned spare tires in here, but you don't have any spare tires on any helicopters. You got them on a few, most of them are skids. So the FAA and the repair station were not communicating. They evidently didn't communicate this clearly because the repair station owner said he doesn't remember signing it. And like I say, we'll get into more details here in a minute. So communication issues there. Next up, complacency. There's a safety net we talked about at the bottom. So when they went in and looked and did the investigation, they started talking to the Turbo Mega Service Center, which was this Helicopter Services in Nevada. And they said, okay, tell us a little bit about your repair station work and then tell us about your field work. So they said when they were in the repair station, they did a complete work order package, and they had the maintenance person do the work, and then they had an inspector come behind him and check the work. Okay. But when they were in the field, they didn't do that. But remember, they're doing heavy maintenance in the field. They really should be doing at their home station. Okay. So they said, we don't do a complete work order package when we do stuff in the field. And so no final inspections are done. So you got one A&P out there working for the repair station, putting an engine together by himself, and I'll kind of go through a little bit of that here in a minute, with nobody checking his work, okay? Which is not good. And I say that's complacency because Helicopter Services of Nevada should probably make sure that did this procedure work correctly, or this policy? It didn't work correctly because they weren't really following their op specs. Okay. And here's your safety nets for complacency. I like that one. Train yourself to expect to find a fall. Now, let me know if I'm going too fast. And if you have any questions, please just go ahead and ask. Lack of knowledge. This is for the pilots. Okay. As the investigation went on, they interviewed the pilots. They knew that a test flight had been done, but it wasn't documented after the heavy maintenance was done on this engine, where they fixed the coking problem on the engine. Okay. So they went to the maintenance test pilot, who's kind of unofficially a maintenance test pilot for Air Methods, and they said, "What checks did you do after the maintenance was done?" Okay, because the engine had been completely disassembled, or the modules had been separated. And he said, "Here's what I did. I did a droop check, a rate of climb check, a cruise power check, flight limiter check, flame out check, auto rotation." So they went into the, I think it was a FADEC. Don't correct me if I'm wrong on this. It's been so long since I've worked on an A-Star. And they found out that that flight took 7.5 minutes. They actually were able to check the time, since the maintenance test flight wasn't documented. And then they went to the Turbo Mecha tech reps and they said, "What should have been done if you disassembled these modules of the engine and did a coking repair on the engine?" And they said, "Well, here are the items in the actual flight manual for this type of maintenance. A hover check, max continuous power climb, max takeoff power check, max continuous power level flight." Okay. And they said it should take 30 to 45 minutes. So you kind of see there. So they interviewed the pilot and they said, "Hey, why didn't you use the manual?" And he said, "I didn't realize they had a checklist in there for that particular maintenance task." In generic terms is kind of what he said. So his lack of knowledge, he didn't do it with intent. He just didn't realize that there was an actual flight procedure to do after all this work was done. So that was definitely lack of knowledge. And there's your safety nets for lack of knowledge. It seems like a lot of times the manuals are always the issue, or get the training on tight. Those seem to be big ones. And the tech rep, I love the tech rep. I didn't know about this that much when I was in aviation. I didn't until I started working in civilian aviation, where they called the tech rep when they were doing some maintenance. The manual didn't cover a certain procedure, and you had to call the tech rep and find out what it was. If I do any acronyms that you don't understand, please let me know. Distraction is the next one. Now, I do have a couple of different accident case studies in here, but that one we just covered is the primary. This is a little bit different story. This is a Bell aircraft, and most of these accidents are induced by humans making mistakes, and this is one of those examples. So this is called distracted. This is a 206 Long Ranger tree. The pilot was conducting a return cross-country business flight in a helicopter, and the weather was good and visibility was at least 10 miles. So you're thinking, you look at that picture, that aircraft that crashed, that's the visibility you would have had, or it might have been better than that, because there's a few puffy clouds in the background. When they did the investigation, they were able to classify this flight. His GPS altitude was between 6,200 feet and 456 feet. The terrain in the aircraft, or the accident area, was 6,400 feet, and he impacted at 6,330 feet. So anybody want to give me a guess on distracted? What do you think he was distracted with? I'm going to let you know right now. He was distracted by something every one of us has. Exactly. Yep. So here's what happened. They went in and grabbed his cell phone that didn't burn up. And they went and checked and found out that he had made a phone call on his cell phone at 4:12 p.m. Okay. So they looked up the number on the phone and they realized it was a rental car agency. So they went to the rental car agency and they interviewed the lady behind the counter. And they said, "Look, did you get a phone call from this number on this date and this time? And she said, sure, I remember that. I remember exactly what happened. She said she couldn't tell that he was in a helicopter, but he seemed busy or distracted. And then she was mid-sentence when the line was disconnected. Well, guess what was happening? Picture this now. I'm not a helicopter mechanic, but I've flown under the table with the Army. But you got to picture this. You got your feet on the pedals, you got your hand on the cyclic, you got your left hand on the collector. You're flying the aircraft. How the heck are you going to make a cell phone call? Yeah, you can do the friction on the collective. That's one hand free. But you got to picture this. He's got a handheld cell phone he's trying to talk on and fly the aircraft. Well, he did. He flew right into the ground. And here's the formula that I determined from this accident. A perfectly beautiful helicopter on a beautiful day plus a handheld cell phone equals this. This is the actual accident picture from when he was flying the aircraft. That's what happened to him. And this is the same for mechanics, except mechanics, if you get distracted by your cell phone, you could miss a step on maintenance and cause an accident too. So it goes both ways. You just can't make this stuff up. Very sad accident. And here's your safety nets for distractions. This is a good one. We do a lot of accident investigations on this one, where a mechanic does work. They get distracted, pulled away. Could even be for a good reason, but they forget where they left off. They don't go back and maybe go back a few steps and then they miss what they forgot, and then it causes an accident. Yeah, this is a good example of that. Like if you're working on a fuel line or hydraulic line, that's a good idea, because if you snug it by hand and it leaks, it's going to be a tiny leak. But if you leave it completely loose and you do a maintenance operational check on the ground, you're going to get gushing fuel or gushing hydraulic fluid. So you're going to know you've forgotten to attach it. But yeah, that causes a lot of accidents too, where they don't tighten all the way and it comes loose in flight from the vibration.
Sir, have you seen on a lot of, in your area section with the distractions, have you seen the majority of companies either work on a laptop that goes back the last 5 steps, or internal policy where they go back to the last 3 steps?
The 3 steps is what I've heard most people do. The 3 steps, or they mark the fact that they didn't finish the job, which is right there. Like they'll put a red flag on something to remind them to go back and look at something. The big thing though is, and this is the way the FAA works with a lot of like Part 135 charter operators, you always want to do there's usually a handoff log that's mentioned, maybe not in here, yeah, right? A detailed check sheet. So even when shift change happens, you're supposed to have that detailed check sheet so that you can do a shift change to the night shift and say, here's what I can do. You need to make sure you do all the stuff after this and double check my work right where the 2 intersect. So that's something the FAA pushes really hard. But you know, the FAA, we let companies write their own manuals, so they get to determine a lot of that on their own. And then we just inspect it and make sure they're doing what they say they're going to do, believe it or not. And lack of teamwork. Okay, so we're going back to our original accident case study. So here's what happened. They had multiple aircraft in this hangar at one time. There were 2 Air Methods guys, and there were the Helicopter Services of Nevada technician. Well, they started taking apart the main accident aircraft, and they got part of the way through the process. They realized they didn't have the resources they needed, so that the Air Methods mechanics stopped working with the Helicopter Services of Nevada guy, and they went to another aircraft and started working on it while he continued to work on this aircraft, taking the engine apart, getting it ready for the parts when they came in. And what that did was it separated those 2 teams who may not have ever worked together before, and it caused the Air Methods guy to do his own inspection on his own work when he assembled it. And there were parts he was covering up that no one could see to go check, like a fuel line. Okay, so lack of teamwork may have contributed to a maintenance process here. So he did all this work, and the Air Methods guys did go look at the engine after it was installed in the aircraft, but the part that he left loose, they couldn't see. They couldn't even access it because he had assembled a cover over it. So I always ask this question: what would have happened if the repair station mechanic asked the Air Methods mechanics to check his work before assembly? This accident would have never happened. Okay. Lack of teamwork. And here are the actual part of the investigation. they went into the actual parts and showed you the parts that came loose and were missing. They found that copper gasket, trying to remember. That's the breakdown, all the parts that had to do with the accident right there. This is the stuff they found. And then, of course, they showed you the parts that were, should have been there. These are the parts that should have been there, and that, some of those were missing, as you can see by the photo. You see that part, and you see the fuel line and the copper gasket. But what you don't see is the bolt, this bolt and this washer. You don't see these two nuts. They probably fell off this plane. Okay. The lack of teamwork. This is what you can do. Communicate. Get that full team. Have people look at your work. Be humble, and that'll get you a long way. Y'all know that in aircraft maintenance realm. Be humble and let other people look at your work. Don't be too proud to where you can't allow someone to say, "Hey, you made a mistake. You need to fix that." I was of the opinion as I got older, I appreciate that because you're helping me prevent an accident. You know, so I think that's a good way to think about it. Fatigue. And this is really similar to the original Dirty Dozen of fatigue. I do hit one case study on it. They get into acute, chronic, and operational. Operational, it takes a lot more time to recover. You need a lot more nights of sleep to recover. And then, of course, chronic fatigue is usually a medical or psychological problem. Acute, you just might have had one night of bad sleep, and you can recover pretty quickly. Usually you notice fatigue in other people before they notice it in themselves because they're usually too tired to tell their fatigue. Here's some of those symptoms. This is a good example someone gave me to kind of compare two different things. They said you can compare fatigue to blood alcohol concentration level on your performance. And you know it's not exactly the same, but it just gives you an idea how you perform. If you stayed awake for 17 hours, you can have a 0.05% blood alcohol level comparison. 22 hours, 0.08, and then 24 hours with no sleep, you get a 0.10. And then you could compare to different countries and what they say you're impaired with. So almost every country is impaired. Up there for 0.10. That aircraft on the top right, we're going to cover that in a few minutes. That was a fatigue-related accident. In that particular accident, the thing with fatigue is you can be affected by changing your sleep cycle. So everybody knows when you do your time change for daylight savings time, you're usually groggy for about 2 to 3 days after that. Imagine having to go to work. So these people at this particular job, as maintenance people, the mechanic and the inspector's normal shift was 12 noon to about 11 p.m. at night. They had to go in and work on this aircraft from 5:50 a.m. till 6:46 p.m. at night. That was the mechanic. The inspector, when he came in at 5:31 and worked until 6:55 p.m. And when they interviewed him, the mechanic said he got about 5 hours of sleep. The inspector said he got about 7 hours of sleep. Circadian rhythm, this is what I was discussing with the time change thing. When you travel overseas, try to get in that sleep pattern overseas, or you're maybe 12 hours difference, that's a big shock to your body. So they found out that it's called circadian rhythms. And if you try to change that really quickly, it's hard to do. You know, the best thing to do is go out in the sunlight, eat your meals when you used to eat them, go to bed at that time you're at. But sunlight is probably the best one. The Marines did a study and tried to make it a quick process, and they never could get it to work. Oh, and by the way, the weakest time for you to work is usually when you should be asleep. And in this case, I think it's like 3 a.m. to 6 a.m. is the worst time for a day shift person to work. That's when you're at your lowest performance. Avoid this complex task at the bottom of your circadian rhythm if you can. Because we know as maintenance people, we don't always get that option. Like when I did that heavy maintenance on that A-Star, we would work through the night to get the job done. So the aircraft would be up as soon as possible. You can't see it, but lack of resources right there. This one also comes into play to our main accident case study. This looks similar to the other slide because it is similar. So like I said, they didn't have the resources to finish that first aircraft. And that's when those two air methods mechanics split off to go work on another aircraft. They didn't have the correct tooling and they didn't have the correct parts. So that other single mechanic was working by himself doing this work. And that was part of the reason, again, that the accident happened. Because they all had to split up. Yeah, go ahead.
Was it the second aircraft that had the accident or the first?
The first one. They all three were working on that first accident aircraft as a team. And then when they realized they didn't have the parts and tooling, that's when those air methods mechanics split off. Good question. Yeah. Very good. Yeah. Which just goes to show you they were all hard workers. They just wanted to keep working and get things accomplished, which is good. But in this case, it didn't work out very well. So the lack of resources was the issue. And again, what would have happened if they had the correct resources? All three of them may have worked on that aircraft continuously, and there would be no case study. We would never talk about it because it never would have happened. More than likely. Here's those safety nets, and this is the big one for that one. And when I worked for Air Methods, I worked for a guy in Columbia, South Carolina named Jeff Shelton, and he's a great mechanic. We ordered the parts and the tools before we started the job. So if we did heavy maintenance in the upstate, he would order all that stuff, have it FedEx to that facility. We'd meet it there and we'd do all the work and have everything we needed. So that's really a good thing to keep them doing. Have those parts ready to go before you start the job. Pressure. How am I doing on time? Am I?
Yeah, good. So Kylie can follow straight after you, so.
Okay, awesome. Good deal. Pressure. Pressure is the next one. There's your safety net down at the bottom. So going into more of these interviews with all the people involved with Air Methods, they interviewed the Air Methods the mechanics and the pilots, the chief pilot. And they said, hey, what's going on before this happened? And they said, hey, we were going to have the CEO coming out for a visit because he wanted to come look at the bases and see how they were doing. So they had to take one base out of service. Usually when I worked for them, they would have, when we did that heavy maintenance, they would fly in a loaner aircraft, we'd take the medical gear and we'd move it over to the loaner aircraft, and then we'd fly the other aircraft up to the maintenance facility to get the work done. But in this case, they didn't have a backup aircraft. So there was a little more pressure to get the job done quickly. You figure back then it was $5,000 for a medical flight. I don't know what it is now, but that's a lot of money if you think about it. But they felt a little pressure because they knew the CEO was coming. They did mention in here that if you didn't get enough business, they would close you down, but they said this one was not in jeopardy of being closed down. They were doing pretty good. And that's basically what they said. He said, yeah, there's some internal pressure on pilots and mechanics because they know if they're not getting enough flight volume, then their base could be considered for closure. But they said they were doing fine. For pressure, there's your safety nets. Next one is lack of assertiveness. This is a U, I call it a U bar graph or whatever. This is a really good graph once you understand it. But so basically, if you're a great person dealing with other people, you're technically right in the middle. But if you're over here on the left for assertiveness, you have low assertiveness, you're passive, you acquiesce, and you compromise too easily. It's not always good to do that because sometimes you need to stand your ground. When you're doing something for safety's sake, you need to be able to stand your ground and then get the other person to prove you wrong. And if they prove you wrong, then you need to be the kind of person who goes to the middle and says, okay, I need to understand that they're saying this is wrong and this is why. And then so if you're really good, you're at the top of the chart and you're in the middle. So you have high performance, and you're in the middle. So you need to make sure you're considering the other person's rights and understanding, and your rights at the same time. When you say rights, of course, that would be if you're comparing a maintenance task and you may have been incorrectly interpreting it. You can listen to the other person, and maybe they're explaining it to you in a way you can understand it. But if you're too aggressive, you don't consider the other person's rights, you just consider your own. So again, the best performing place to be in a service is right there in the middle. Lack of assertiveness, here's your safety nets. Refuse to compromise your standards. If you're doing things the right way and following the manual, then you don't need to compromise if it's the way it's supposed to be done. And if you're not sure and you're not arguing about it, you can always call a tech rep, they'll explain it to you. Also, make sure you record everything that you do and only sign for what is correct. Stress is the next one. We're going to see the same chart, and it's real similar. Anybody want to tell me where you should be? You want to guess? Right in the middle? Yeah, middle top. That's it. The same situation with stress. If you get too much stress, people will actually shut down with too much stress. I've seen it in the military when they put us in these big exercises and we stayed up half the night, we're exhausted and we have so much stress on us. Some people will shut down and quit doing things because you've got so much on you, you become fixated and confused. But if you're sitting in your parents' basement on the couch, you might be on the low zone. You get out there and get a job. But anyway, that's the complacency, okay? Complacency is not always good, and so you want to make sure you've got a little bit of stress there. You don't want to be so low stress you don't want to do anything. Okay? I always like that example. And there's your safety nets for stress. I like this one for mechanics. This is like the holy grail. When you got your hand up in an area that you can barely move your fingers to tighten a nut or something, and you're exhausted, you just take a break or take a 5-minute break, come back, all of a sudden you magically can do it instantly because you've rested and you're not stressed out. I've learned that with many aircraft. They make them hard to work on. Lack of awareness, the next one. Okay, this one is we're back to that main aircraft that we were talking about. So when they did the maintenance, they topped off the aircraft and they put the flight crew in it, which is a standard thing for Air Methods or any kind of helicopter operator. And they flew to their next location. They say it would have only been a 55-minute flight, but they said they had too much fuel to go to the other station. Well, we know from the FAA, we want you to have extra fuel. It's not a bad thing, but they claim it could have been a problem during the auto rotation, having that much weight. That's a questionable one or lack of awareness, and they claimed it was just below maximum gross weight. They also found out that it had actually overflown an AD, requiring an engine inspection for the cycles. They actually accrued 518 cycles, and they were supposed to have it done at 500 cycles. Again, this is that Swiss cheese. You're starting to see all these holes line up. Probably the AD did cause the accident. This one probably had a little bit of an effect to it, but now here's another thing I found. This is one of those interesting facts you find out when they really dig deep on the investigation and do a really good job. These medical ships are modified. Air Methods would get a supplemental type certificate, which allowed them to modify it for medical air transport. They take the left seat out. Let me make sure I'm right here. I got to make a picture of myself in the aircraft. They take the left seat out and they put the litter because there's a sliding door on the left side of an A-Star. And so you basically had a big piece of plexiglass that surrounded the pilot to keep the patient from swinging and hitting them and if something went wrong. But so they do a lot of modifications to the aircraft to make it an air medical ship. But they did find out that Air Methods had done something that wasn't authorized. It was never documented with the FAA. If you do a change to an aircraft, it should be in a Form 337 saying you made the change. You submitted to Oklahoma City for them to have it in the records. Okay. But they found out when they did the investigation, they found out the rotor RPM gauge was in the bottom left corner of the instrument panel, which was not where it should have been according to the Airbus guys, or back then it was Aerospatiale. They found it in the bottom left corner. Does anybody want to tell me why that's important? I'm sure I got some pilots in here. Anybody want?
Yeah, you say you auto rotated, right?
Exactly, yep, that's the instrument, yeah, that's the instrument gauge you use to auto rotate, correct? And if it's way down there, you got a picture of this, you're sitting like this and the gauge is down here, near your left knee, that's not probably where you want it when you're trying to auto rotate. Okay? And it's mentioned in here, it was a primary instrument used during auto rotation. They never found the documentation showing that was authorized to be moved. Another one of those Swiss cheese items making it harder for that pilot to do that auto rotation.
I guarantee you that every pilot at the base said, why is this tack down here below the trim ball,
Oh, yeah, yeah.
turn coordinator? Why is it? Yeah.
Yeah, and it's just, it never made it to leadership, I guess, or people that needed to know about it. Sometimes it's good to complain, especially if it has to do with safety. This is another accident that's completely, different than the ones we kind of investigated before. This is called lack of awareness. This is one of those weird deals. I think you and I spoke about, is Zach, right?
Yeah.
We spoke about this earlier. This is a guy, and this is one thing we've seen in a lot of commercial aviation with helicopters. They want pilots who have AMPs, okay? Because it's a money saver for a company. This guy's out remote. He's doing helicopter swing operations, okay? And so he does his own inspections and stuff on the main rotor blade. But it mentions here that he was on an external load operation when one of the main rotor blades separated, which caused a loss of control and collision with terrain. Helicopter rolled downhill. You don't see many helicopters roll downhill, but that's the perfect one to roll because it's designed almost like a teardrop, which probably saved the guy. The aircraft sustained substantial damage. They found that one of the 4 main rotor blades was fragmented in many pieces. Well, the 5th blade was found about 900 feet from the main wreckage and had less damage. They found out that it had separated due to fatigue cracking that had initiated near the root end. And the reason it's a lack of awareness, well, it's probably more than lack of awareness. So the aircraft pilot has airframe and power plant certificate, and it was specifically so he could do these inspections. The AD, everybody knows ADs are required, airworthiness directive. You have to do it per the FAA. It's not optional. Service bulletins are a different story, as we all know. But the FAA said that if it's an airworthiness directive, it's got to be done. So he was supposed to be doing an inspection after every 200 torque events. Okay? Or at the end of the day's operation. Now, when it says or, that means if you reach 200 torque events in one day, you got to stop what you're doing and do the inspection. Or if you do less than 200 at the end of the day. Does that make sense to everybody? And it required the operator to record the number of torque events on each main rotor blade. But when they interviewed the pilot who has AMP, he said he usually exceeded 200 torque events per hour, not per day, per hour. And then he didn't perform the inspection until he got home at night.
How do you define a torque event? What's
Now
the
that's,
definition?
I don't understand the whole process. I know that we used to record cycles on A-stars.
Yeah.
But I'm assuming it's like, does anybody know? I don't know the correct answer to this. I'm assuming it may be a lift.
From an aviator point of view,
Right.
does that mean, I mean, that's a lot. 200 torque events per hour, is that every time you change the torque by % or pound or whatever the.
He was doing lift work, wasn't
He was, yeah.
I mean,
he? Yeah,
how
so
much-
every time he did a lift and then dropped the load, that would be a torque event.
That's what I'm assuming.
200 per hour? Man.
Yeah.
Yeah, I mean, I've seen some of these videos where they're
To me,
literally
that
just,
sounds like every time you.
Oh, yeah, yeah.
He had loaded or unloaded, that's,
Yeah.
isn't that a RIN?
Really?
What they call a RIN?
Yeah.
Recorded,
Never
yeah,
mind.
recorded.
No, that's a good question. I don't understand. You're probably correct. I don't understand either.
But
I
I think
probably
it's
could look it up.
each time that you have a load on there
Yeah.
and that you complete the load and drop it, that's considered,
That's working
I
in.
forget exactly what the RIN means, but that would be a torque event. 200 per hour.
That's a lot.
That's.
there's that great,
that's
one of the
a lot.
great videos of like a guy moving Christmas
Sounds like He
trees,
might have also been lack of awareness of mathematical
one
computation.
place to a truck, and it was literally like
Yeah.
Yeah, unless
a
he,
minute per, less than a minute per operation,
Oh, yeah.
and he was just literally.
Well,
I could see if he was dropping Christmas trees,
sure.
because those guys do that much work in an hour.
Yeah,
Oh, yeah.
They do that much, but he was flying
Yeah, they don't mention what he flipped in an accident investigation, but my thought is my butt's in that helicopter and they say to do it every 200 torque minutes, I'd be doing it. But he didn't, so he risked his life and he survived, so his gamble paid off for him, but not for his employer, because they had to replace the helicopter.
And James, I can help with that a little
Yeah,
bit.
go ahead.
Because the utility guys will typically, they have a new way to check the tubulum on the old wooden poles. Telephone poles of lesser voltage, not the high towers and everything.
Sure.
They still get inspections, the helicopters are very efficient for doing that. And people will go, it's working the tubulum to the signal, so if they do a couple miles, that means.
Sure.
That the utility company doesn't want to spend the money to replace them.
Right.
They have clients that they can do to keep them changing out on that infrastructure.
Sure.
And they're so busy building new infrastructure, so 200 torque events per hour is, that's a lot. You don't really take a break if that's what you're doing, but a particular check, or in other words, the cross member of an old wooden pole
Sure.
can do that.
Oh, wow. Yeah. It's amazing the stuff we can do with the helicopters. I don't think drones are ever going to be quite there.
Wind starts on retirement index number.
There's the actual blades. My life depended on that, and I was that pilot, I'd have been looking at those things.
He's
Exactly.
lucky that that vibration didn't snap his neck and kill him.
Yeah, that's true, because I'm sure when it rolled, it probably was not like a carnival ride, I'm sure.
But you had a helmet on it.
Yeah, I'll never. So lack of awareness, think of what may occur in the event of an accident. He found out, really, didn't he? Ask others if they can see any problem with the work done. In his case, he wasn't following the inspection procedure on that particular blade, and it almost cost him his life. Norms. Norms is the last one. We're gonna go back to that accident I talked about earlier that had fatigue involved, so we're almost done. So this is the actual accident. So it was a tourist flight, that was responsible for December 7th, 2011 crash of a Sundance helicopter, Eurocopter AS-350 in the mountains of East Las Vegas, the National Transportation Safety Board said. I may hit my notes if I still got them up. That's all right. So here's what happened. They were doing maintenance on this aircraft, and they disconnected the fore and aft servo at the top. And this is what it should look like when they put it back together, okay? I've done this a couple of times. But what they did is they did the investigation, they found they were reusing the self-locking nuts. Now that's okay if you're following the manufacturer's requirements, if you check and drag torque, if it's allowed, which is where you make sure that the self-locking capability of nuts still exists, you can reuse them. But in the military, we don't reuse them, we throw them away because we got y'all's tax dollars to pay for them, I hate to say it. But we always just replace them. But some civilian operators will go by the drag torque in the maintenance manual. But these guys were not doing that. They were just reusing the self-locking nuts and not checking the drag torque. And that's what it should have looked like. They had a they had a crew on, and they had the passengers on the sightseeing tour. And so this is what happened. And this is not.
They didn't put the cotter pin in.
That's correct. We're gonna hit
That's, I'm
that too. You're
real
exactly
familiar
right.
with that crash. And
You are, yes, good.
those guys did not use the cotter pin. They reused the lock nut because they were like, I don't know, 40, 50 bucks a piece. And it was a norm to reuse them.
Yeah.
Because they did so many flights.
Yeah, and like I say, it's okay if the maintenance manual says you can do it, but if you don't, it's big trouble. But you're exactly right. The cotter pin was not installed either. Remember we talked about fatigue with the mechanic and the inspector? Well, the mechanic did the work, the inspector was supposed to look at it. Well, how do you look at this and not notice there's not a cotter pin in it?
Because there was no paperwork.
Well, that's a problem too, but yeah. So.
That's the other reason that this failed.
Yeah. So the NTSB came out and said, I love this, inadequate maintenance on the helicopter, including the improper reuse of a degraded self-locking nut and the improper or lack of installation of a split pin. Is that what the French call it?
Yeah.
That's
they
what
call
we
it
call it.
split pin.
Okay,
Yeah,
split pin, yeah.
Okay, good. Okay.
The
that's
French
why
call it
I was
split
wondering.
pin.
I put cotter pin because cotter pins.
Yeah.
Yeah, I wouldn't, I know what a cotter pin is, but we would always use split pin in
Yeah.
aircraft maintenance concepts.
Now that makes sense. So they probably got it from the tech rep, I bet.
Yeah, it actually, yeah, if it's a Eurocopter, then
Yeah.
for sure they would use split pin.
And inadequate post-maintenance inspections. Guess, tell me who the other person you should have looked at the aircraft. Who we forget, we talked about the mechanic and inspector.
Wow.
The pilot should have done a pre-flight. I would have looked.
He
If I
did.
was the pilot, I'd have said, what'd you guys work on? And I went and looked at those areas they worked on.
4 people looked at that.
Really?
The check pilot, the pilot that flew, the inspector,
Sure.
the pilot, the check pilot, the pilot that flew and killed everybody, and the mechanic.
Wow, man, that's just.
4 people looked and they all didn't see it. My
It's hard to
understanding
see,
was
too.
the reason they didn't see it is
Yeah.
because there's a syndrome called you expect to see something there, so you don't look for it.
Yeah,
And that's what they went through.
I believe that, yeah.
Okay, but they would have had to test fly it, then test flew, okay?
They have a
Didn't
check
come to
pilot.
us until later, though.
Okay.
You know, helicopters vibrate so much. You can have that nut all the way home, but if it starts backing off, it might take an hour or 2 to start loosening it up.
4 flights
4 flights is, yeah, so,
Okay.
and 5 people were
My
killed.
answer.
wow, that's really sad, yeah. And I appreciate the input. It's good. I love the fact that you get people who know about the action, who know more than I, want to keep close to it, know what about. So contributing factors were the mechanics, the inspector's fatigue, and the lack of fully delineated steps for the maintenance task and the inspection and ETS steps. Okay, so we showed you what it should look like, right? And you notice it's got a little shroud over it. It's like a plastic or fiberglass shroud, which probably makes it even a little harder to see. I'm sure that's there for corrosion and
Yeah.
keeping water off of it. So here's what it looked like when they went and did the accident investigation. There's the hole that the nut should be mounted right there. That's what they found in the accident. That was like the aha moment for the accident investigation, okay? There's no rod connected there.
Did the nut just come off? That looks like the bolt sheared.
The nut just loosened up until it fell off.
Fell off.
And then the bolt came out.
Contact.
Yeah.
And he lost 4.5 cycles.
So he, when it came off, there's nothing he could have done to get it on the
Oh.
ground. There's nothing. Good accident though to study. Norms is sort of like what you're saying. You get so used to doing something, and you see something, but this norms is you do a process over and over and over.
Well, yeah, it was the
It
norms
shows
to
your life.
reuse it, but the other thing too was that you expect to see something
Yeah,
and you look for it and you just know that it's always there.
what do you call it, like expectation bias or something like
Yeah,
that?
I forget exactly. what
Yeah,
the term
yeah.
is.
Confirmation
Yeah.
bias.
What is it?
Confirmation bias.
There you go, yeah, that would be, yeah, that's
That's the
fine.
human factor term.
Yeah. And this is a good one. Norms, the FAA is terrible, by the way. We call it tribal knowledge, where another inspector teaches us what to do, but we don't follow the guidance. But norms is the same as tribal knowledge. Okay, there's Dirty Dozen. The movie was based on the name, at least. And this is space reality. Everything that we do can cause a death if we're not careful. Somebody told me the other day that he worked at a bearing manufacturer, and they would tell the people who manufacture the bearings that you can't pull an airplane over to the side of the road. You gotta be able to do it right and make sure it's safe in the air, right? Charles Taylor Award. If you don't know about the Charles Taylor Award, you may not know about it if you're a pilot, but the Wright brothers would have never flown their airplane without Charles Taylor. He made the engine in 6 weeks from scratch for the airplane because the Wright brothers had sent letters to all the automobile manufacturers and said, hey, we need an airplane, we need an engine that doesn't weigh any more than 120 pounds and can create at least 8 horsepower of energy or brake horsepower to fly the aircraft. They all wrote back and said it couldn't be done. So they got their bicycle shop mechanic, Charles Taylor, to make one from scratch in 6 weeks. He actually took the crankshaft, he took a block of metal and made the crankshaft from scratch. So he's a forgotten, unsung hero, but if you have 50 years of aircraft maintenance experience, military and civilian combined, and you don't have this award, we can get you one. So just let me know if you're interested. Or you can submit someone you know that is eligible. The same requirements are for pilots. As long as you've never had your certificate revoked, you can get a Wright Brothers award. So, but I always like to mention it because he's a humble guy. He worked for the Wright Brothers when they were selling their airplanes, but then he ended up leaving them because one of the brothers died, and then he ended up going to work for North American Grumman during World War II. And Ford was building a museum, like a museum setup that was real similar to what all the buildings look like that they did all their work in and everything. They couldn't find him. So they hired detectives to go find him. They went to the airplane manufacturing facility. They found him and they interviewed the people around him and said, hey, did you know this guy? The guy who made the first engine on the airplane? They said, no, we didn't know. They never told us. So he's just a humble guy building aircraft, and he's the guy who invented the first engine for the first airplane.
Yeah, he died of a heart attack. He's buried at the approach end of Burbank Airport.
Oh, wow. Yeah, that's right.
Right.
That's good stuff. Yeah.
Didn't he come up with 12 tap horsepowers today?
He did. Yeah, I think he made it lighter and more powerful
Yeah.
than what they asked for. Which is, and if you read his history, he didn't even know that much about engines. He did a little bit of research and built this engine from scratch. I just couldn't believe it.
Yeah, he said he did it by posted notes, and they put a note up on there and he would just copy the notes and then do what he had to do.
Yeah, it's unbelievable. Here's my information. I'm from South Carolina, but there's a FAST team program manager in every state. And we also have volunteer representatives who've been helping out in the back with these QR codes and helping out in the background, manning the stations out there. So if I can ever do anything for you, please let me know. I will do everything I can to help you and support you. But thank you for attending. I really appreciate your time.
Thank you.
So welcome back to everybody in the room we have and all the people we have virtually as well. And we'll get straight into it. And a huge welcome to Kylie from the FAA, who's going to do our final presentation of the day. So Kylie, I'll hand straight over to you and we'll get going.
Okay, great.
Thanks for joining.
Give me just a second to figure out sharing my screen. All right. And if I make it in presenter mode, does it look correct?
Yes, looks good.
Okay, great.
Yes, it looks great.
Well, hello, everyone. Thank you so much for the opportunity to share some of my research with you today. My name is Dr. Kylie Key. I'm an engineering research psychologist. I work for the Civil Aerospace Medical Institute at CAMI. CAMI is our initials. FAA is who I work for in the Flight Deck Human Factors Research branch. And that's a lot of words to just say that I do human factors research, mostly in the area of aviation maintenance. And so the project that I'll be briefing you on today is called Safety Culture Assessment in Aviation Maintenance. We have developed a new tool and we have some preliminary validation evidence to share with you all today. So starting with the basics, we like to level set by defining how we view safety culture. We view safety culture as an index of how much employees perceive that their organization values safety over other competing demands such as productivity and production. It can also be defined as the emphasis on safety at all organizational levels, from the frontline employees to senior leadership. And in particular, leadership is a critical driver of a positive safety culture. Finally, it can be viewed as the extent to which risk-taking behaviors such as failure to follow written procedures are viewed as necessary to ensure timely completion of tasks. And in fact, in aviation maintenance, one of the most common human factors issues that occurs is people not following the written instructions. And when we do research to try to identify why that behavior is occurring and how we can improve it, one of the root causes or contributing factors, if you will, always traces back to the safety culture and whether there's a culture of corner cutting. And so for these reasons and many others, the research sponsor prioritized safety culture as a focal area for FAA. So we know that a positive safety culture is foundational for effective safety management systems, but even if your organization doesn't have a formal SMS, there are still many reasons why a positive safety culture can be beneficial for your organization. So we know that safety culture has been linked back to many important organizational outcomes. If you have a positive safety culture, then you'll experience, on average, positive increases in safety-related behaviors, such as wearing PPE, voluntary reports that are submitted, performance, productivity, and even profit. And in part, that's because safety culture helps reduce some things that we don't like to see in organizations, such as non-compliance with written procedures errors, incidents, accidents, personal injuries, and turnover intentions by the workforce. So these are just some of the good outcomes that can come from a positive safety culture. And more so, why we're doing research on this topic is that safety culture has been ranked as one of the top human factors challenges, and researchers and working groups of industry personnel have stated that a well-established safety culture is a critical foundation that must be in place before many of the other human factor challenges can be addressed effectively. I love this quote because it says safety culture is a critical foundation. We have to start there before we can really mitigate many of the other human issues that are going on in our organizations. And without a positive safety culture, SMS cannot function effectively. Like I mentioned, you don't have to have an SMS in order to have a safety culture. In fact, every organization has a culture. It's just on a continuum from good to bad or positive to less healthy. And so what we're interested in doing from a research perspective is to start to measure safety culture and then start to help make meaningful improvement. So when we talk to people across the industry, we go to events like AVS InfoShare and conferences like this, and we talk to people and everybody seems to get why safety culture is important and have an interest in understanding the safety culture in their organization. It's clearly beneficial, but where we start to see things fall apart is in terms of how to assess and how to promote safety culture in a meaningful way. And so these are the basic, at a most basic level, this is what the research that FAA is doing is designed to address: how to assess safety culture and how to promote it. So we began by looking at what's already available. And there are over 1,000 safety culture assessment tools. I am not going to brief you about all of those. And I'm not going to, go too in depth about what's already out there, but I will say that the research sponsor identified some challenges with the existing assessment tools. Many of them are proprietary, they cost money. They may require researcher or consultant support to administer the survey, look at the data, and then figure out what to do with it. And they also may not suggest areas and methods for continuous improvement. So now that I have the data, great, how am I supposed to improve? Many of the assessments that are already there fall short in these ways. And so for these reasons, the research sponsor requested that we would develop a new standalone do-it-yourself safety culture assessment and improvement toolkit, and this is specific to aviation maintenance. So we called it the FAA MSCAPE, and it's a survey instrument packaged along with data analytic tools that help identify specific areas for improvement. And what we were tasked to do is first develop these tools, second, test them to determine whether they're scientifically valid, and then finally, after everything is shown to be beneficial, then we are supposed to transfer it to industry. And I'm really pleased to report that we've covered these first 3 bullets and now we're working on the last one. So I hope to be able to release this toolkit soon to the industry. But for now, I hope that you'll just enjoy hearing about how far we've come in terms of safety culture assessment. And knowing that the goal ultimately was for us to do basically a test case to demonstrate that this tool has some use and then release it for you all to use. So again, I don't want to bore you too much with the science, but I wanted to give a huge acknowledgement to where the survey came from. It's important to recognize that our survey was not developed on a whim. It has its roots actually dating back more than 2 decades ago. There was a lot of work done in the military environment in Australia, and Dr. Fogarty and Cooper and others have developed this instrument. Originally, they called it the Maintenance Environment Survey, and then it evolved over time. Now they call it the Snapshot. And the Snapshot survey assesses many different aspects of an organization's culture. And it has been demonstrated to be valid in the military maintenance environment, again, dating back 20 years. So we chose this one as a starting place for our survey because we're pretty darn sure it works. In part, the reason that it works is because it's not developed on a whim. It's actually based on a theory of organizational performance. And it's important to have a theory because it means we have a shared language. We know what to assess, and we can show how different parts of safety culture interact with each other, they overlap, and how we can use a safety culture to promote better outcomes for our organizations. So the theory is called the job demand resource model. And what the model says is that the organization is responsible for providing resources and demands to the employees. The employees, in turn, have their own set of behavior and outcomes like engagement, and their behavior and outcomes are going to transfer back to shape the organizational outcomes. So what that looks like a little bit more is the organization gives the job resources and demands. This is resources like communication, supervision, importantly, management commitment, equipment and tools, documentation or written instructions, and so on. Job demands are anything that hurts performance. So overload, workplace restraints like scheduling hassles, unequal distribution of work tasks, coworker or safety concerns. And together, these job resources and job demands influence the individual employees. One misconception that people will have about safety culture is they think that it's just defined as employees' commitment to safety. But what we're trying to promote here is that employees can be committed to safety, but if they don't have the right resources to do the job, they're still not going to do it right. And so that's why using a model or a theory like this can really help illustrate what are the drivers of safety culture and how are we going to be able to change it. So the employees' outcomes are things like their satisfaction, workplace morale, how strained and fatigued are they, and just their overall well-being. It also includes compliance behavior. This shapes organizational outcomes like their willingness to report, performance errors, compliance, accidents, incidents. You can imagine the list of organizational outcomes going on and on and on. But again, this picture just illustrates that on the left side here, the organization really is what shapes the culture. And by changing the resources and the demands that employees face, we can help them perform more safely. And if they perform more safely, then that translates to better value ultimately for our organizations. So I'm going to stop talking science now. That was enough or even too much. I know you didn't come here to hear about a theory, but what I will say is that each one of these topics, even if it doesn't seem like it, really does have some relationship to safety culture. And the reason I wanted to show you all of these things is to kind of debunk the myth that safety culture is only about employee commitment. And also because if these things all drive safety culture, then we need to be measuring them all. And so our survey actually does that. And again, based on the snapshot survey for Australian military maintenance, which also measures all of these things. So with the snapshot survey as our starting point, we adapted the survey to civil operations in the United States. And again, we were supposed to be developing a survey specifically for maintenance safety culture in aviation. And I'm pleased to report that we've done that. So on the left side of the screen, you can see what it looks like from the participant's perspective when they're completing the survey. So the survey is an anonymous web-based link, and it is compatible on any web-based device. So laptop, personal computer, cell phone, tablet, the list goes on. So this is what it looks like if the employees complete it from a cell phone. They're asked to indicate how much they agree with or how frequently they experience all of the topics in this diagram. So they are asked, what about communication? What about commitment? What's the level of equipment and tools being adequate in your organization? How frequently do you experience fatigue? how frequently do you not comply with procedures, and on and on and on. So I chose these example items about management commitment because management commitment really is a critical driver of safety culture. So for those topics, employees were asked to report how much they agree with management values safety. We receive managerial support even if following safety rules affects operational activities, and that management is committed to our safety objectives. Previous research has shown that employees' perceptions of these questions is really critical as a part of your safety culture. So I just use those as an example. But again, the survey measures each one of the topics in that blue diagram. And we developed this survey and then we tailored it to 4 different operators. The operators were a large MRO, a small MRO, a military maintenance organization, and then a medical helicopter organization. And for each one of those operators, we entered into a voluntary partnership with them that said, we will administer the survey for free in your company, and then the data will come to us as a research organization. It cannot be used for oversight, surveillance, or any other nefarious purposes. We just need to establish the validity of the survey itself. We're not looking at you as a company, we're looking at the tool. And we customized it so that it would be really meaningful and impactful for them as companies. We tested it with all of them, and after we received all of the responses, we reported the results to each one of our collaborating organizations. We have a total of over 900 data points. I'll tell you more about those in a little bit, but I just wanted to tell you the extent of the testing that has really gone into this survey development. And after we have reported and briefed the data to all of our collaborators, now we're aggregating all the data together to see if we can make one bigger picture of safety culture and whether this thing actually works. So that's the research stage that we're in right now. We've also shared it with FAA. So one question is, if it works for industry, great, but can it work for us too? So that's something that we're exploring. And we believe that we're now at the point where we can say we have validated the survey and the scoring criteria, and we are preparing to release it. So I just wanted to take the time to share more about our validation method. So utilizing the FAA MSCAPE, here are our methods and results. And at the end, I'll tell you what this all might mean for you. So I mentioned just a second ago that we have over 900 responses now. That is true, but at the time that I did these analyses, we had 424 across 4 companies. So again, we had a large MRO, small MRO, military maintenance, and a medical helicopter organization. The survey was tailored for each one of those, but they still use the same core set of questions so that we can compare responses across the different organizations and we can kind of tally up all the responses on average. We administered our first round of the survey during the COVID-19 pandemic, so take all of these results with a grain of salt, but that's just the time that we were at in the research. As soon as we got the survey ready to go, unfortunately, we entered into the pandemic, but we had already established really good collaborations with multiple organizations, so they were gracious enough to allow us to administer the survey anyway. So we customized the content for them. We used the Qualtrics FedRAMP platform. It's a cool survey administration tool. And the little QR code that's here, I hope it's still functional, but if you take out your phone and you scan it, then it should take you to a preview of our actual survey if you're interested to see all of the questions that we asked. And we did guarantee confidentiality for all of our participants. So again, the data can't be used to harm the companies. It can't be used to harm the individual respondents. We're interested in aggregate results across all of the companies just to see if our survey works and is a valid way of measuring safety culture for the maintenance industry. So starting to dive into the data a little bit more, first I'll tell you about who our participants were. You can see that again, we had over 400 respondents. 36% of them were maintainers. 44% were frontline leadership. 11% were upper management or leadership in the organizations. And then 9% were other, like support roles. The majority of the respondents had been with their organization less than 10 years, worked first shift, and worked several hours a day, 9 to 16. So fatigue was a pretty prevalent finding that we found in this study. Next, what we did is, I'm actually going to go back, so that's not too much visual for you to look at. So all of the respondents completed our survey, and for each topic that we were measuring, we asked multiple questions. Remember, I already told you about management commitment. If we want to know about commitment, we ask at least 3 things, right? And so for each one of those topics that was in the blue diagram I showed, we asked multiple questions about that topic. And so now we know at a topic level, where are the organization's strengths and where are their opportunities for improvement? And so we reported the data to each one of the companies so that they could take action. And then we averaged everything together across companies. We're not looking at a single company anymore, but we averaged everything together to see the overall picture for the industry, at least the companies that were sampled. How are things looking? And so here's an example of how we did the data analysis. Again, this is averaged over all 400 plus participants. Remember that they rated their agreement or how frequently they experience each one of these things. And that can be scored on negative, moderate, or high or positive with red, yellow, green, respectively. And we have a bar for each one of the topics that was in that blue diagram. I'm showing job demands because I think that it's another really important driver of what's going on in the organization. And it also represents a pretty good opportunity to improve in maintenance specifically. And so these are the most harsh data that we found in the survey. And I just use them to illustrate how we really can see what's working well and what may need improvement. So what we would like to see ideally is longer green bar, meaning positive perceptions. And if we have more red and yellow, then this indicates more opportunity for improvement. Also, if the bar is shorter, then it indicates more opportunity for improvement because it means employees on average felt worse or more negatively about that topic. The red vertical line here indicates the average across everybody, across all topics within job demands. And so when we look at the data this way, we can see that across the organizations that were sampled, employees had really positive perceptions about some things like bullying. Almost no bullying is occurring. They also felt pretty positively about safety concerns and personal role overload. So am I overworked? No. But interestingly, there are also some areas where we can improve, and those would be about workplace restraints. So do we schedule fairly? And do we give people enough notice of variations in their scheduling? Unit role overload. So in my division or with my colleagues, are we overloaded? Yes. And then regarding coworker concerns. So this is things like, do we all do an equal share of the work? No. And are we promoted to supervisory positions too quickly? Sometimes yes. And so again, by looking at the data this way, it helps us know where we're already doing fine. Safety concerns, bullying, we're already doing fine. But there's also some ways that we can improve. And so we reported to the companies, and we have also analyzed the data this way for every topic that our survey assessed. And in summary, we saw that across the companies that were sampled, their strengths include most job resources. So employees feel pretty positively about the training that's received, the equipment that they're provided, and the supervision that they have. They also indicated strengths in terms of individual outcomes, so satisfaction, fatigue, and organizational outcomes. So how they feel like the organization is performing and also their compliance behavior. Where there were more opportunities for improvement were in job demands. So again, the task overload at a group level, And it says safety concerns, but it should say coworker concerns. Sorry about the typo. Now, that all reflects on what's going on in the companies, but there are also opportunities for us to improve as researchers. And so here's some of the feedback that we need to grow in. Our survey is really long. It takes like at least 30 to 45 minutes on average to complete, and that's just resource intensive and maybe not practical for organizations. So after employees finished reporting about their company, they also reported to us about our survey usability. And they did say that reducing the survey length would help improve usability. And they also said that they weren't sure how the results would be used by their company's management or FAA. And so that's improving their understanding of how the results will be used is another opportunity for us to improve. And then as a final note, I'll say that we tested the survey and it seems like it works really well for the maintenance performing organizations like MROs. One criticism that we got is that we don't know how well it works for the GA community and we don't know how well it works for airlines. And so basically, can we take this and make it have value for other aviation sectors? And the answer is yes. We now have also tested it with one airline, bringing our total number of respondents up to over 900. And we are still analyzing and compiling all that data and sorting through it. But in the very near future, we hope to be able to release our official report about the findings totaling the MROs and the airline, and then identifying how the results can be used by real companies. And then we are working to try to figure out how we can translate this tool for other communities such as GA. And it can be hard to administer a survey when your company is so small. And so working on scalability is definitely an area of research interest for us moving forward. So other disclaimers here. We only completed a survey and self-reported perceptions can be biased. So the survey results need to be verified using objective sources. That's something that we're looking into moving forward. Good data sources could be audits, voluntary reports, and root cause analyses with event investigations. Just be aware that self-reports can be biased, and also the sample that we had may not be representative. So the companies who participated may be, more willing than the average, we don't know. And also the participants who took the time to respond may also not represent their companies. And so that's one way that that's a reason that we would need to confirm these results using more objective data sources. And also, as I already mentioned, the survey was administered totally during the COVID-19 pandemic. And so that may impact the results. So we've got the survey and it seems to add value to the industry, but now what? Well, we're still trying to determine how to integrate other sources of information like the objective data into one bigger picture of safety culture and the risks faced by the organization. So all I can say is that we acknowledge that this is something that we need to work on, and we are actively researching that. So I believe that we've demonstrated with our data set that this survey is valid and valuable for the aviation maintenance industry. So now that we've kind of done this proof of concept, the next question is, am I, Kylie He, going to administer it to companies forever? No. The sponsor's intention all along was for us to release this toolkit for free to the industry, and that it should be standalone, do it yourself without the need for researcher or consultant support. And so our next steps will be to develop training and scoring guidance. So we already know how to look at the data, but translating that for the industry is something that we're actively working on. And then also identifying mitigations for each area of improvement. I showed you on the bar graph, we can figure out what are the weaknesses, but how to improve those is a whole separate beast. And so we're working on that. And then finally, broadening the scope, as I mentioned, we've already expanded it to work for the airline community, and now GA will be hopefully our next step. Some key points that I covered are that safety culture absolutely can be assessed, and it's important to do routine assessments as part of overall healthy safety management. we can find areas for improvement if you look at the data in a granular enough way. We provided some initial validation evidence for our new FAA survey called the MSCAPE. And now we are still doing research to improve its usefulness, and we're preparing the toolkit for public release, hopefully any month now. I would say day, but you know how it goes in the government. That is what I prepared to brief to you all today. Thank you so much for your time and for the opportunity to share these findings with you all. My contact information is here. Please feel free to reach out with any questions. And as a quick acknowledgement, the research that I presented was funded by ANGC1, our Human Factors Research Division of the FAA, and it was conducted in support of the Aviation Safety Flight Standards Service. And I will pause, and hopefully there will be time for questions.
Thanks, Kylie. And yeah, for sure, that was the next question. So anybody got any specific questions for Kylie? Yeah, we've got one.
It actually might be a two-parter. First of all, how does Kylie see the survey fitting into, say, a background that's beyond SMS, for instance, ASAP, and then the former MSAP on the maintenance side? How does she feel that it could support those? And then the secondary question is, when do they think they're going to work out the biases? Because if 11% is management on the pie chart, that's a huge bias.
Did you catch that question, Kylie?
Yes, I heard the two parts. Is it okay if I answer them in reverse order, though?
Yes.
So first addressing the large percentage of management who responded. Yes, you're right that management perceptions tend to be much more favorable than that of frontline employees. And so if our sample had a lot of management in it, then maybe our results are skewed. That's totally true. But as you saw on the example bar graph, there were still definitely some identified areas of improvement. So it's not like management was able to convince us that everything was fine all around. I think that this means that the survey, even though management still responded to it, it is sensitive enough to detect where there are areas of improvement. And again, one of our next steps will be to figure out, how can those areas be improved. I do appreciate the comment, though, about the misrepresentative sample potentially. And what I'm hoping is that once we release this to industry, then there will be a ton more data about, other companies administering it and everything. And I don't know about us being able to get our hands on that as FAA, but if we could, then it would certainly empower us as researchers to continue to do analyses to make sure that our survey is still working across time. So that's like a pie in the sky dream of mine that I have. I don't know if it'll actually happen, but fingers crossed. And then the second question that you asked was about how can the survey be used to support programs like ASAP? I don't know if I've ever been asked that before, but what I'll say is that I think that they're complementary. In ASAP programs and in this safety culture survey, we're asking employees to tell us their perceptions of their workplace. What risks are there? What hazards are there? What resources and demands do they face? And so I think in that way, they're actually complementary. There are obvious differences, though. You report in ASAP when something goes wrong. You report in the culture survey whenever your company decides to do one, and that may be yearly or less frequently than that. So there's definitely differences in the frequency of how often we get data from these two sources, but I think that in the most basic sense, they are both trying to capture employee perceptions of their workplace. So I view them as complementary. And I would also hope that we should see if employees in the survey say we have a problem over here, then shouldn't they be reporting that in ASAP as well? I would hope that that would be the case. And that's still a question that we're researching, though. So we only have access to the survey data right now, not also the ASAP reports. At least at the company level. And so we can't really make that comparison right now, but it definitely seems to be a logical way to move forward. So I'm hopeful for that. Did that adequately answer your questions?
that capture
Yeah, just a final comment to challenge Dr. Key. Or actually make a request that maybe she look at the continuous improvement side of ASAP and she'll find the home that I'm trying to describe.
Okay,
it? Yeah, I'm kind of interested in that as well. So at a European level, we have, I take ATM, we have something called the ATM performance scheme, and within that, organizations who are already doing kind of the equivalent of the ASAP, then have an annual, no, it's not organized, yeah, it's done through the organization. And they also then have a culture survey as well as other things.
Right.
So
Reviewing continuous improvement.
yeah,
Otherwise, how are they going to show the continuous improvement and how the programs evolve?
I guess it's whether may be interested on Kylie's thoughts on this is, I guess it's whether, you know, the safety culture survey, when we do it as like an annual snapshot, and it's whether, you know, I guess it has multiple uses potentially where you can pull it out and do it as a one-off. And as soon as you do it more than once, there's like a link to continuous improvement of the cultural aspects associated with that.
So we can even trend off of that. So those are all, you know, considerations that I've asked Dr. Key to look at as it comes together.
Did you catch that a little bit, Kylie?
yes, thank you all so much for that feedback. I'll just say that I agree. Linkages across multiple data sources would be super helpful. And I just wanted to make it really clear in case it wasn't already. This was a research activity and we are hoping to release the toolkit for free public use, but it is not required. It's optional and voluntary. And in the future, when companies start to use this, FAA won't have access to the data. So we're not planning to make it mandatory. And I'd say that in that way, if ASAP is already giving you all the data that you need to make it continuous improvement, then I'm so happy that you have that tool. We just made this one as another resource that companies could use. So I hope that that helps reduce any panic if there was any.
Maybe there is an evolution where the tool, you know, this in itself becomes part of the continuous improvement.
Yeah, I'm looking for a tool, not a new policy.
Yeah.
Right.
I mean, we see in Europe, challenges in Europe where, yeah, we have requirements that organizations have to do, but how they do that is a lot more open in a performance-based regulatory environment, which is where things get interesting. You say, you know, do X, but you don't explain how to do X. And the more, but that's why my safety promotion team exists really, is when we say do X and everybody in industry says how, then we set up a little team and go away and figure out the how, which is just so exciting.
Useful tool.
We're really helping.
Yeah.
Any other questions for Kylie specifically? No? Cool. Thanks very much, Kylie. If you're happy just to stick around for a few more minutes, because I had a couple of, well, first of all, I was going to ask, is there any questions for any, we've still got some of our panelists in here and the presenters. If there's any questions for any of them on any of the things that we've done today. And then just before we finish, one thing I'd like to just maybe, well, we've got a few minutes, is we talked particularly yesterday about, you know, the challenges for the helicopter community in general, and particularly it was more operationally focused, you know, flight crew training and all these things. I'd be really interested if anybody's got any particular thoughts or comments on what are the biggest challenges the maintenance community faces right now? You know, is it similar? Is it, you know, challenges with not having enough staff, or, you know, what are the main things? Yeah, sure.
Northeast maintenance helicopter, I find a lot of the places I audit, they're all going to the allies.
Yeah.
Well, money. They cannot sustain helicopter technicians.
Yeah, I think that's one of the things that we see in Europe, and I guess maybe it's something we see collectively across the industry.
American Airlines, Delta, United, the packages, you got to pay the people.
Yeah, particularly if you're in small organizations with tight margins, that becomes harder and harder. And it, yeah, it's a continuing challenge. Any other big challenges that anybody see? Push it a bit late.
I would just, for me, and this is probably speaking for the training aspect of it, is I would like to see more technicians do some follow-on training. I just don't see that enough. I doing the European side, seeing how they really get into the groove of training, whether it be recurrent training or extra practical training that's kind of just required in some of those agencies.
Yeah.
Seeing that firsthand, and then seeing the kind of technician you kind of get from that, and you're like, oh, okay, that's good. But then I got, some people that take a 2-week course, I'll never see them again for the rest of the time they have the helicopter. There's so many things that go on and change that really could capture some of that information, make them better at what they do on the backside of it. So I would just, that's something that it's like from a training aspect, I would like to see, not a requirement maybe, but something that, something some of the companies can buy into, just getting some more training.
And actually, one thing I particularly took away mentally for the future work that we're doing particularly in the VAS safety promotion team is, assuming with that fact that there are people who aren't doing that, maybe the discussion we have in the safety promotion group is, is there a role for us to help support, at least trying to get information out to those kinds of people so that, well, if they don't have a reason to go and get further training, how can we provide, something that helps fill the knowledge gap at least a little bit as part of some kind of collaborative activity? Maybe there's a template we work with each of the manufacturers on and kind of help fill in the blanks. I don't know what the solution is, but
I think
I'll say that way in chat. We'll chat about it.
You got my contact information. You
Yeah,
can
yeah.
just reach out and
Yeah, for sure.
we can do that.
I think his online course is very good. Just the
Virtual courses, yeah.
that reduces the operator's costs for traveling, that's a lot of things I see they don't want to pay hotel out there.
Yeah.
But the virtual is great.
Yeah, that was one thing we were thinking just have to do it out of necessity. I said, but then like a year later, when COVID was totally over and people could travel, they still want to do virtual courses. To keep the technicians at home. And I get it, it's a long stretch. You're doing training for 2 to 3 weeks and having somebody out of pocket, but when they're doing virtual training, have the opportunity to train, plus to stay at home, be on the phone and all that stuff. So
we have a thing we started doing it as part of the implementation of evidence-based training for flight crew. But as part of that, there's a group developing, it's actually doing it at ICAO level now, is what they call competency to tool, and saying, well, what competency do you get from different tools? So it's a practical, if I do real on-the-job training, on a real aircraft, for example, a helicopter, I take these competencies, but it's then acknowledging that, yes, I can do the job by doing virtual training, but you don't achieve these competencies as soon as you do that. And so at the moment it's being done for flight crew, but one of the next discussions I know a few people at ICAO level or global level are having is, well, let's do that for other job functions. So you can say for engineers, similarly, okay, if you do practical training, you get this lot, but there are these, you have to acknowledge that as soon as you step into virtual training, you save money on costs, but you create these other risks because these competencies aren't as effectively trained, which is all kind of really interesting. Cool. Yes.
More operator and OEM involvement in apprenticeship type operations, I think, are necessary. I mean, if we don't get some more buy-in from the operators, the lack of mechanics that are coming out of the schools, which is low to begin with, and the pickings coming into the helicopter side are small because we're the smallest part of the industry. We're going to have to get more involvement where an operator or the OEM will jump in and do some apprenticeships to get these younger people into the industry. There's too many of us guys that have got, gray hair and pacemakers. We need more behind us, and they're not showing up.
And actually, it's interesting. We've started to see already quite a growing cultural shift, I think, in people starting to acknowledge the challenge. We've got certainly us in Europe, and I know through ICAO's Next Generation Aviation Professionals program, there's lots of questions between different authorities across the world about how can we do this in different countries and come up with different models for different job functions that reaches young people at an early age, encourages more diversity and that kind of thing. Particularly we've got whole programs in Europe at the moment on encouraging young women at an early age that aviation is an exciting and interesting career that can give them a really interesting future, and trying to kind of tap into pools of future workforce. And then, like say, how can organizations
partner or whatever with training establishments so
Right.
that there is a clear career path. They don't just go to training and then they have to go, oh, what's available?
Well, their interest in coming into the industry is different than why I
Yeah,
came
yeah.
into the industry. And that's something that I guess we're gonna have to figure out is how to find that culture and find what attracts them to do something like this. And then bring them on. And, you know, they're push buttons and cell phones and stuff. And
Yeah, there's a lot
The old
of
guys
kind of
aren't.
fundamental shifts
Yeah.
that we've been talking about that a lot is even just in organizations that, you know, young people coming in have different expectations of, or even their organizational kind of in eco and, you know, environmental sustainability approach. And you know, there's so many things that
Yeah.
I see organizations starting to talk about. It's really interesting. Any other thoughts or questions? I mean, it's been quite a long day, so thanks for sticking with us. If there's nothing else, have a great evening and we'll see you at 8 o'clock bright and early tomorrow morning for the final day. Thanks very much.
Thank you.
you.